That one, center of circles will lie on an axis. A general planar motion, or what you can call further, we give name rolling motion here. So here what happens, the body will have the rigid body will have both translatory and rotatory motion. Okay, what about the examples? How do that object will appear? So I think we need some diagrams, no? There's only definition. The object will have both rotatory as well as translatory motion. So here, I'll draw that rigid body. I think shape drawing will be difficult. After some time, the orientation of the body will be okay. Look at this. So now let's take the 2 points. What will happen to those 2 points in this curvilinear motion, or say like a general planar motion? This point A is available here. There's a point A, and the point B is available. So how it has moved? So I'll draw a path. You can see, you know. See, distributing points will not change, but look at the orientation of the line AB. This is very important. That the displacement of points and the orientation of line AB also has changed, you know. Look at AB, earlier it was making some angle, now it is making some other angle. This is example of general planar motion. Here what will happen? There will be the translation occurs with respect to a within a reference plane. There will be a translative motion. In this, what is the plane? XY plane. In XY plane, it is undergoing translative motion. And rotation occurs about an axis perpendicular to the reference plane. So what is the reference plane? XY, that one. So here, where is the translative motion? I'll see. Translative motion is in XY plane. What about rotative motion? So where is the rotative motion? Rotative motion about Z axis. So what's happening to body? The body is spinning, and also it is having a translative motion. So there's a displacement of point in. Now look at this one. Sir, how do we analyze this? There should be some method how you can say that there's a rotation as well as translative motion here. I'll take a simple mathematical approach here. I'll just give mathematical proof so that will be easy for you. What do you mean by this general planar motion? Later on, I'll go exclusive discussion. There's a first class, no? Let me give the suitable example, that one. So let me take a, there's only introduction to have a general view. When we enter into rolling motion, we'll discuss in detail all the things so with mathematics. So just what do you mean by translative? Let me give an example. Okay, there's a body I chosen. So let me choose 2 points, A and B. Is having translative motion. So let me define the coordinates of this be XA coordinates of this be xb. So shall we take this is xb, this is xa, and vertically along y-axis this will be ya, and this should be the yb, and there's a line joining a and b. The body is rotating about an axis perpendicular to the plane. Will I agree this? I think already I just shown this one. The body is having both rotatory as well as translatory motion. How do we describe such a motion? So let the distance between point be L. Then what is xb minus xa? Should be equal to L sine theta. Then yb minus ya, or ya minus yb will come. Ya minus yb. L cos theta. So let me take this is theta. Let me differentiate this. Vbx minus Vax should be equal to, this should be L cos theta d theta by dt. I'll differentiate this. Vay, Vby equal to L minus L sine theta d theta by dt. So what is Vbx equal to? Vbx equal to Vax L cos theta d theta by dt is what? Omega, no? Are you now able to define what is this d theta by dt? Angular velocity. So this will be omega. So Vay equal to Vby, or in terms of Vby, let me write it here. Vby is equal to Vay. Vby equal to Vay plus L sine theta omega. What are Vbx, Vax, Vby? Velocity of points along x-axis, velocity of point B along y-axis. And what is Vx? Velocity of point along x-axis. And also it's having angular velocity. Here the particles are having both. These velocities are with respect to what? You should tell me very clearly. What is omega? Angular velocity. And what about Vbx and Vx? They are the velocities with respect to origin. About an axis, about z-axis, you can take it. It is spinning about an axis passing through one of the, so like here, the body is rotating, not z-axis here. The body is rotating about an axis passing through one of the point in a body, that one. I think somebody is asking axis. Omega is about axis. So either you can treat it like it is rotating about the point B, rotating about A, or point A rotating about B. You look at the theta, how I'm taking this one. About omega is about an axis passing through point A and perpendicular to plane of the body, or parallel to that axis. So now what is the generalized method here? How to study such motion? Different points, what are Vbx, Vax? They are the velocities with respect to origin. So shall I say they're describing translatory motion. And what about rotating motion? Rotating motion is given by omega. So how to study such motion? So usually what happens, what I do is like, with respect to some point, so what actually happening, the B is, shall I put it simplest way? B is, point B is rotating with respect to point A. See, I'm going to conclude a very generalized way. If a body is having, if a body describes general planar motion, both translatory, rotatory. So what is the idea will be there? I know the velocity of translatory motion. So I know how to calculate the velocity with respect to some reference point on origin. These are what due to translatory motion. I'll write it here. Uh, Point B is rotating with respect to point A with angle to omega. What are VBX and VX? VB bar and VA bar? Velocity of point A and B with respect to origin. So these are translatory motion. These VB and VA, VB bar and VA bar are due to translatory motion. What about now? The omega, due to omega, what will happen? It will, the point will be rotating about a certain specific point here. Yeah, I took here point A. Usually what happen, we generally take the center of mass, about center of mass, they'll be rotating. So in general planar motion, what will happen? The points will have translating motion and all points will be rotating about some point on a rigid body. Or it need not be always, see, it's always need not be about point A. The points can rotate about some other axis also. Here I'm choosing the axis is passing through point A. I defined omega as d theta by dt. And always, and the axis need not to pass through a point on a rigid body. It can lie outside also. Are you able to understand? So what is the example of this? The best example of this is like the wheel of a tire. So the wheel of a vehicle, the tire, rotating tire, wheel of any vehicle you look at, it's going to describe motion of this particular thing. So definitely I think a lot of mathematics is involved. You can see here now. So how to calculate velocity of any point? I know angular velocity. I know angular velocity. These are what only translate. What is the total velocity? You should take the vector sum of the translative motion and the velocity due to rotative motion. Then you're going to get this one. So suppose I will take example of the wheel of a vehicle. It is moving here. The center of mass will move like this. And all points will rotate about with an angular velocity about center of mass. Then what about velocity of this point? Due to center of mass, Vc, due to rotative motion, it will have r omega c. Then what is the resultant velocity? Vp bar should be equal to Vc bar plus r omega c bar. Like this, I'll find out. So this is due to translative motion. This is due to rotative motion. Here open, the points are rotating about center. The resultant velocity you should calculate here. So this is a general planar motion. This I'll discuss exclusive rolling motion. Just I should give a basic picture because some problems we do where translatory rotative motion are there. So this is due to translatory. This is due to rotatory. Okay, fine. So let's take the, now I'll bring to the concept of torque. There's only introduction.